Hi guys, in this very lesson, we have a physics question, a beautiful one at that to solve. Before we solve this question together, I'll give you some time to try this question out. Okay, let's see if you're one of those that solve this question right. So what do we have right here on the board? A and B are 2 points, 162 meters apart. One car passes A with speed 5 meters per second and is accelerating uniformly toward B at 3 meters per second squared. A second car passes B at the same instant with speed 7 meters per second and accelerate uniformly toward A at 2 meters per second squared. After what time and at what distance from A do the cars meet? Now, in our previous set of lessons, we worked on two-dimensional motions and one-dimensional motion. So there's a one-dimensional motion here. This specifically acceleration of bodies along the x-axis. So if you've not seen that lesson, go ahead and see that lesson for you to be able to understand what we're about to do. So we have two major points, more or less like checkpoints. We have a given checkpoint here, and we have another checkpoint here. So these two major checkpoints are 162 meters apart. 162 meters apart. So this checkpoint A and this checkpoint B. So according to this question, one car passes A with a speed of 5 meters per second. So there's a car at this very junction. There's a car here. Let's just manage this image. So this very car passes this very checkpoint A with what speed? With a speed of 5 meters. So I could say this is initial speed for car A, 5 meters per second. Car at checkpoint A, and it's accelerating towards B. This is accelerating. So we have two major checkpoints, A and B, 162 meters apart. So a car passes this very checkpoint A, moving towards checkpoint B with a speed of 5 meters per second, and it's accelerating uniformly at this rate of 3 meters per second square. So acceleration of this also is 3 meters per second squared. Now, at that very instant that this very car passes checkpoint A, another car was doing the same thing, was passing checkpoint B. So look at it, say a second car passes B at the same instant with speed of 7 meters per second and accelerate uniformly toward A at 2 meters per second squared. So we have a car doing the same thing at this very other checkpoint. Now, but this car is moving with a greater speed of 7 meters per second. And acceleration also for this very second car passing through this very checkpoint is 2 meters per second squared. Now we have two major questions here. After what time and at what distance from A do the cars meet? Now when this car passes this place, and we have a second car here. Let's have another image like this. Now this car passes A, moving towards checkpoint B. Now at that same time instant, everything happens simultaneously. I mean, so as immediately this car passes this very checkpoint, another car also passes this same checkpoint. These events happened simultaneously. So these two cars moving like this, facing each other. So it definitely means that they will get to a certain level, a certain point, that's in between these two checkpoints, and they will meet in between these two checkpoints. So after what time and at what distance from A do the cars meet? So we don't really know. They didn't tell us the very point where these two cars meet, but we're very much aware that they will meet somewhere in between. So let's assume that they both meet at this very junction, at this very point. So let's say the two cars meet at this very point, but we don't know the distance, so we're just going to assume. So we're going to assume that that this very car B, this car B, this car A. So this very car B, let's say this car B was about X meter away from this checkpoint A, from this checkpoint B, I beg your pardon. So if this very car B is X meter from checkpoint B, it means that car A will be how many meter? Don't forget that the total distance between the two checkpoints is 162 meters. So if this very car is X meter away from this very checkpoint, it means the other car, you understand, at this very point where they meet, will be 162 minus X meter away. So now don't forget this what it's going to look like. When they meet at this very point, we are not told the point. So this will be 162 minus X meter away, while this will be X meter away from this very checkpoint B. So what are we going to do? The next thing we're going to do now is we're going to use our equation of motion. And the best equation of motion to use is S equals to UT plus half AT squared. So we're going to be using this very equation of motion to solve this very question. Okay, let's take off a portion of the board to solve up this very question. So we're going to take off this very portion. We have all our parameters already. We have everything we need to solve this question. So what do we do? So we're going to be using our s equal to ut plus r theta squared. That is the best fit equation of motion to solve the very question. So we're going to be solving the very first car. That's the very first car A, and this car B here right here. Now don't forget, there's something that these two cars share in common, and that's what we call time. For the fact that this movement, the movement took place at the same time, so it means that they shared one thing in common, which is time. So this car leaves here, passes checkpoint A, the other car passes checkpoint B, or past checkpoint B, I beg your pardon, past checkpoint B, and this past checkpoint A at the same time. So it means that while they were moving towards each other, they spent the same, time interval to meet at this very point. So for car A first, that's for car A, you have S equal to UT plus R at squared. So don't forget the time is the same thing, but the distance is quite different. So for the very first car A, this is 162 minus x meter. Now initial speed is 5 times time, then plus 1 over 2. Acceleration is 3 times time raised by 2. So what do we have? Now 162 minus x equals to 5t plus 3 over 2 t squared. So we have this. I can call this equation 1. So now then for car B, let's solve for car B. Let's see what we have for car B. We're going to use the same thing. S equal to ut plus r at squared. So what distance? This is distance of x meter equals to initial speed is 7 t. That's the time, which is the same. The time is the same. The time for B is the same for the time for car A. So acceleration is 2. Then the time is by 2. So 2 year 1, 2 year 1. You have s equals to 7t plus time squared. And you have everything set off. So now if this is equation 2, right here. So now if s is 7t plus t squared, that means you can fix x into this place to solve it. So we're going to do that. So once you can fix s into this place to solve this up. So what do we have? We're going to do that right away. So let me take up this portion. Take out this portion. So what do we have? The x is 7t plus t squared. So that means we're just going to substitute equation 2 into equation 1. 162 minus s is 7t plus t squared equals to 5t plus 3 over 2 t squared. So what do we have? This 162, open up the bracket, minus 7t minus t squared equals to 5t plus 3 over 2 t squared. So now what I'm going to do next, we are going to collect the like terms. We bring all the t's together. That's t raised by 2, then t raised by 1. This is absolute, quadratic equation. So this comes over and this comes over. So what do we have? We have the 3t squared plus the t squared, 3 over 2 t squared plus the t squared. Then we have the plus 5t. This crosses plus 7t. And this crosses also minus 162 equals to 0. So what do we have? The next thing we have right here, I can just say this over 1, over 1, over 1, over 1. So the SM of all this is 2. So 2 into 1, 1 times this 3t squared. 1 into 2, 2 times this 2t squared. Then 1 in this, that is 10t plus 14t. 1 and 2 is 2, then 3 times this is minus 324 equals to 0. Now once this happens, what's the next step? What it means is that the LCM is gone because of the equality sign that we have. So what do we have? 3t squared plus 2t squared will give us 5t squared. 10t plus this will give us 24t minus 324 equals to 0. So we're going to use our calculator to solve this very quadratic equation. So we have a quadratic equation right here. So we're going to look for the value of t. Let's quickly get that done. So you're doing that. You're going to use so Let's see what we have. So 5t squared, so 524, and minus 324. So let's see what we have. So S1 is 6, then S2 then is minus 10.8. So T1 is 6 seconds, T2 is minus 10.8 seconds. So we're going to go with this. Time should be in positive, result. So the time it took this whole event to take place or to happen, the time it took them to meet together, you know, this very first car leaves checkpoint A. The second car, the very first car left checkpoint A. The second car left checkpoint B. They did that at the same time simultaneously. So they both met at this very position. We're going to solve for that. Now, it took them 6 seconds to meet each other. Just after 6 seconds that the two can meet at this very junction. So you can see that already. So time is 6 seconds. So now let's solve for the distance. The distance, we're going to solve for x. So how do we solve for x? If t is 6, then s is going to be what? X will be 7t. T is 6. 7 times 6 plus. Then what do we have? 6 raised to power 2. 7 times 6 is 42. 6 raised to power 2 is 36. What do we have? 42 plus 36 will give us 78 meter. I think that's correct. So x 70 plus t squared. 7 times 6, and then 6 raised to power 2 is 36. So we have 78 meter. So what it means is that this very stuff was 78 meter away from the very checkpoint B. So if it's 78 meter away from very checkpoint B, then this very car, that is the car A, the car that moved in from checkpoint A, that will be 162 minus 78. 162 minus 78 will give us what? 162 minus 78. 2 minus 8 is not possible. We'll borrow from here. We have 5. 12 minus 8 is 4. 15 minus 7 is 8. So that's 84 meters. So this is 84 meters. So what does it mean? It simply means that according to the question, after we are asked how long it's going to take them to meet, which is 6 seconds, that's correct. Now the second question was, um, after they've met, the two cars, meeting, what distance, will it be from checkpoint A? Now these two cars are met here, so what distance would they be away from checkpoint A? So they'll be 84 meters away from checkpoint A after the met here. But they'll also be 78 meters away from checkpoint B after the met here. So there's the absolute result. So we're done with this very lesson. So if you found this lesson helpful or resourceful, please subscribe to this very channel at Edu Mosaic, and also follow me on Facebook at Revelation Up. And please share this lesson also with others. See you in the next lesson. Thanks.